Hello everyone, welcome to this session on contest taking strategy. Before starting, can just give a thumbs up if I am audible and visible in the Unacademy chat. In the chat box on the right of the chat box, you can give a thumbs up to say if I'm audible and visible. Alright, so we have 9 thumbs up, nice. So I'm live on YouTube as well, so that's great. So let's wait for some time for people to join in. Until then, let me give you a introduction of what this session is about and what I'm going to be telling you guys about, right? So this session is focused on contest taking strategy. It is a 1 hour session, and I will be talking about how to give contest and what mentality to have before a contest, during a contest. The during the contest part is the most important, of course, and what to do after a contest. Many people kind of ignore what to do after a contest, so I will also be talking about that, right? We I will also be let me also introduce myself for the people who are new and do not know about me. So I am Zeus Ors at Codeforces. I am a international Grandmaster. Where I was All India rank 1 a little time ago. I am currently All India rank 4 on Codeforces. And I am NM at Codechef.com, where I'm a 7-star programmer, and I think All India rank 8. Recently, I've also joined as an educator at Unacademy. So, just give a thumbs up if you do know these sites, Codeforces and Codechef. I'm not sure how many people of you know, but just give a thumbs up if you do know about Codeforces and Codechef. I'm going to be talking about how to give contests on these sites specifically. There are also other online contests as well. Apart from Codeforces, Codechef, there is AdCoder, there is HackerEarth, there is HackerRank, many places. LeetCode doesn't necessarily do coding contests. It does do weekly and bi-weekly contests, but those are more oriented towards uh, really oriented towards DSA. But yeah, that can be called contest as well, right? So this was an introduction about me. As more people are joining in, let me talk about the Unacademy platform as well. So in the Unacademy platform from tomorrow, uh, batch is going to be started. So this batch, does a batch mean? If you are coming from the class from Tanush Khattar, you most probably have heard what a batch is from him. But let me, if you are joined this class specifically without going to Tanush's class first, let me talk about what a batch is. So, a batch is a yearly plan, a yearly structured courses of making you, a master in computer programming from starting when you do not know anything about programming up until getting you mastery in computer programming. It is a complete structured course of 1 year. There are many courses in there which will tackle many different places of programming, and this is what a batch is, right? So in this batch, there will be a structured learning for complete beginners. You do not have to know anything about programming to get into a batch, and you will get to become expert level coders as you get to the end of the batch, which is after a year. Highly competent technical minds like ICPC World Finalists are there, IOM medals are there. People, Codeforces I'm an international Grandmaster. I will be teaching in this batch. So this, all of this will be the points in this batch, and there will also be a Codechef certification exam at the end. So after you have completed the batch, you can get a Codechef certification that denoting that you have completed this batch, and also telling about uh, how you are completed it. And the expense is lesser than INR 90 per day. So you are spending only like rupees 90 per day to get into this batch and learn this structured way, right? So rupees 90 is not that much. You might even spend like more than 100 on your like fast food habits on a day, right? So you can get this whole structured planned course for less than your fast food eating habits uh, in for this whole year, right? So what you will get in this structured course is in these courses you will get live interactive classes. First you will attend these classes which will be interactive like this one. Then you will practice the relevant problems at Codechef. We will also be providing the relevant problems on Codechef. You can directly go to Codechef and practice those problems. And then if you have some doubts, you can get those doubts resolved by us or teaching assistants. We have a Discord server and we have some forums where you can ask us doubts directly, right? So after the classes as well, you can get those doubts cleared by us. And then you attend the next class, you then practice problems related to that class, you get your doubts cleared. So this is a cycle in which you will be learning in these batches and in these courses. uh, the difference here from a free class that Unacademy has, the difference here is the problems and the doubt part. You do get a live interactive class, but you do not get the relevant problems, which is the majority part, as we will see later in the session. The problems part is the majority part. You can also find problems by yourself, but that would take you time. We have like a fresher in a college who is getting into computer programming spends almost like 60% of his time researching in where to study from and how to practice, right? The 60% of his time is only spent researching, and that is a lot of time that you are wasting on other that you can spend on practicing itself, right? So if you do decide to join an academy, you do not have to worry about where to study from, what resources to consider, what resources are actually good. You do not have to go about and ask that. You do not have to go about and ask like which questions are good, which sites are good. You will all be getting that. You will be getting the best problems that we know. You will be getting the best points for each topic that we know, right? So this would all be covered in a course: the classes, the problems, and the doubt support. So this batch structure, which we are starting from tomorrow, will have these courses in three different streams. You can these streams are divided by the language you prefer. So there is a stream on C++, there is a stream on Java, and there is a stream on Python. Whichever language you prefer to learn about, you can choose that stream, and each stream you will get introduction to programming, an introduction to programming in with a language, sorting, searching, basic data structures, additional concept in Java, greedy algorithms. So this will be the first beginner part that you will be getting. Then the data structure, square root decomposition, number theory, recursion, and DP, discrete mathematics. This is the intermediate part in computational programming that you can talk about. And excuse me. Then there is the advanced part. You might have heard about segment trees a lot, graphs a lot, advanced dynamic programming, computational geometry. So this is the advanced part. So you will be getting all of these courses as the year goes on, right? And not only these courses, there will also be different courses that you will be getting, right? You do not have to necessarily only follow these. There will be other courses as well, and you can follow those courses as well if you get the Unacademy subscription. Uh, to get this batch, you just have to get an Unacademy subscription. And if you get an Unacademy subscription, you get basically unrestricted access to any course you want, any paid class you want on the Unacademy platform in the competitive programming goal, right? So these are all the educators that will be teaching you in this structured courses. Tanush Khattar, he's a two-time world finalist and also teaches in IUI camps, right? Which is he's a really good educator. Sanket Singh, he's also a software development engineer at LinkedIn and has qualified for GSOC. Pulkit Chabra, also high ratings on Codeforces and Codechef. Triveni Metha, he's a world finalist. Himanshu Singh, a world finalist. So these are all the people that will be teaching you in these courses, right? And have taught in these courses. So you will be getting these courses. This is the batch that we are starting from tomorrow. And in this batch, let me summarize what I have talked about. You will be starting from a complete beginner, and you will be getting to an expert level coder. What is the difference? Like for me personally, I have researched my own things and practiced my own problems. But again, the time I spent on that could have been saved by like just taking the problems from a really curated source. That's what we are providing you. We are providing you curated problems. We are providing you the information that you need to know in these classes, and for you will be saving around 60% of your time if you do try to, like, if you learn from here, instead of if you're trying to find resources yourself and trying to see which resource is good, all of that research time could be saved if you try, if you spend your time here, right? And also, spending your time yourself can be a little risky because it is not always sure that you're getting the right resources. It might happen that you're just spending your time on the wrong resource at all times, so it might happen that you are not gaining anything from it. So that will be saved here. So this is the forum where you can ask teaching assistants doubts. This is the course-wise practice problems, where all of the course-wise practice problems will be provided. The the subscription plan, the pricing of it is, for 1 month you can get it for 5,400. You can expand it after that as well. Less than rupees 90 per day I was talking about was a 12-month program where you will be giving around 30,000 for a whole 12 months, right? You are getting 54% off, and you will be getting the Unacademy subscription for 12 months, which is the complete year the batch is going to run. And if you're in like first year or in second year, just starting it, and you get this batch right now, then by the end of the year, you will be expert level coder and ready to face any placement interview or intern interview, or even beyond that, right? As well, you might not even have to think about those anymore. So you can get these. You can also apply a 10% off by the refer code capital E small n capital E small n. If you do apply this refer code at checking out, you can get a 10% off here. And finally, this converts to less than rupees 90 per day, right? So you're spending 90 rupees per day on your learning and getting to a good company. So in colleges, of course, the fees is much higher than that. So these are also the courses that are already available on the Unacademy site. You will also be getting access to these, right? You will not only be gaining access to the batch that is going to start, but you will also be getting access to all of the other courses that have been completed or are going to be conducted from now on, except the batch system, right? Except the batch system, there will be other courses as well, and you will be getting access to these, like here. And yeah, just let me confirm, are there any doubts regarding this batch system? If there are, just give a confused face, or if it is clear, just give a thumbs up, and we will move on to the contest taking strategy on today's session. Right? Also, a reminder, if this is going to be a really interactive class, so you might have many doubts, right? So just ask them in the Unacademy chat or the YouTube chat. I will be looking at those all the time and trying to answer them all the time, right? So if you want to ask me anything about your own journey or roadmaps, you can ask me that as well. So let us start about the contest strategy. So I've divided that into the before a contest, what you should do, during the contest, what should you do, and what you should do after a contest, right? So right now I'm going to be talking about what you should do before a contest, right? So there is, it can further be subdivided into long-term preparation, short-term preparation. You do not have to memorize this in this way that I have written, but you have to take it the points that I'm going to be talking about, right? So in the long-term preparation part, there is only two things that are kept here, which is the practice and the learning, right? These two things are also that Unacademy provides, practice and learning. Practice you won't be getting in the free classes, and learning you won't be getting in a structured way in the free classes. Both of these you will be getting in a structured way if you do avail for the subscription program, right? But the 95% rule, what I have written here is that even if you're studying from anywhere, your practice should be 95% compared to the 5% of learning. After learning 5%, right, the ratio that you should deploy on your practice part should be 95%. That is a 95% rule, right? This can be relaxed a little bit, but the most it can be relaxed up until should be 20-80. It shouldn't be like 50-50. You are learning most of the time and practicing just 50% of the time. That cannot happen in competitive programming. Competitive programming is just an area where your practice matters a lot. Your own practice, right? The ideal is of course 5%, 90%. You can relax it until up to 20%, 80%, but you should be practicing most of the time. You shouldn't be stuck on only learning new concepts and only learning about you know like new tricks or new optimizations or new stuff. You should be practicing. In the starting part, I think it can be relaxed a to 2080 because you do not know a lot of stuff, and you should be learning about a new stuff so that you can solve more questions, right? So it can be relaxed up until 2080, but still the practice part is 80% of your time. Only 20% of your time you should be studying something. So the learning can be done from video lectures or reading, right? So video lectures can be online, like from Unacademy, or can be from other sites as well, you know. And on campus, this is a little going to be a little maybe controversial, because in my campus the learning that I got for data structures and algorithms was really nice, but it still wasn't enough for to prepare for interviews, for intern interviews or for placement interviews. What that is a final goal that most of the people are looking forward to. Or even if you're looking beyond that, if you're looking for getting into the ICPC World Finals and IIA World Finals, it is purely not enough for that, right? The learning that you get on campus is just not enough for really competitive areas such as interviews or Codeforces or Codechef or ICPC IOI. It is just not enough for that. So the on-campus part only teaches you about the basic data structures, right? The majority part you have to learn online from video lectures, or you can read about them. Maybe you want to learn about a new algorithm, you can just Google that, or you can learn from a book in a structured way as well, right? So this is the learning part where you can learn from. And the practice part, what I want to talk about in the practice part is majority of your practice should come from contest itself, right? This is also a part where many people kind of not follow, because the majority of practice that they do are from questions themselves. They open up Codechef, they open up the problem set, or they open up Codeforces, they open the problem set, and practice from there. They do not participate in contests, right? This can be okay if you are preparing for ICPC or IOI and you are competent enough, but you wouldn't improve very much in performing contests. To improve your rating or improve your contest performing ability, the majority of the practice comes from contest itself, because if you're participating in contests, you're getting used to the 2 hour time period, you're getting to the feel of how you should solve problems in contest time and stuff like that. So the majority part is contest, or can be virtual contest as well. Virtual contest, it is a term which is used to describe that for solving a contest just like you would have solved in contest, but you are solving that contest at a later time when the contest is not running right now, right? If you're solving the contest at a later time, but just like you would have solved it like in real time, right? That is called a virtual contest. In Codeforces, it's easy to apply for a virtual contest. You can go to any contest and just start up a virtual contest. Or in Codechef as well, you can go to a previous contest and see all of its problems and solve it like you're doing a contest, right? So the majority of practice comes from contests and virtual contests. But there is also topic-wise practice, right? The practice that you should do apart from these contests should be topic wise. They shouldn't be a random practice. They should be well, I'm weak in DP, or I have just learned about dynamic programming. I should go to the dynamic programming topic and practice problems on that, right? So that is a topic wise practice that I'm talking about. Or the difficulty wise topic, if you do not want to go really high in DP problems, you want to stay to the intermediate level of DP problems, then you sort the problems according to the difficulty and solve according to that, right? So that is a topic wise or difficulty wise practice. And then there is a short term preparation for a contest. which is just before like 15 minutes or 20 minutes before a contest, you should relax and focus yourself, right? You should focus your mind, and you should completely relax to be able to perform, concentrate in the problems that are going to come in the contest. Verify you are registered, of course. Just verify one time that you're registered for contest. Set up your coding environment. That is the kind of stuff that you do just before a contest. But the main part here is the relax and focus, that you shouldn't be worried about how you're going to perform. You should just be worried about how you're going to be solving those problems, right? uh, your performance shouldn't matter in a contest. This is I'm going to be talking later on about that as well, about your mentality part, how you should have your mental preparation during a contest. But you shouldn't be worried about your performance even before the contest begins. That is like the worst thing that you can do, right? A2OJ is good for that. Yeah, A2OJ is also a good site. But that only I think it offers only difficulty wise practice, and I think only difficulty wise practice is not that good. Topic wise should be the primary goal. You should practice problems that you feel you are weak in, right? Difficulty wise is just to like not go like really low or really high. You should always, you know, solve problems at your own level. But if you're just solving problems randomly without no topic attributed to them, then you should, I think, prefer contests or virtuals itself. You should practice from those, right? So any doubts relating to this, or any doubts you want to ask me, you can ask them in the academy or YouTube chat, of course, and I will be answering them. So if there are any doubts, you can ask them. Let me go on the next slide right now. So in contest strategy, which is the majority part that you should be focusing on, that what should be your strategy during a contest, right? We have talked about what you should do before a contest, about your preparations, but in a contest, uh, your mental preparation and your strategy matters a lot as to how you're going to be performing. Not that you should be worried about how you're going to be performing, but you should at least try to perform good, right? Did you have any set of problems that must do? Any set of problems that one should do? I don't think so. I don't think there is a set of problems that everyone should do before. Like, there are some classical problems that you should attempt just before an interview. But if you're starting out in computer programming, I think you should avoid those questions, right? You should try to solve those classical type of problems just before you have intern interviews or placement interviews, so that it is fresh in your mind and you can go answer them if they are asked in the actual interviews. But you shouldn't solve those problems earlier, because they are kind of doesn't mix really well with the Codeforces problems or the Codechef problems. Those are much more towards your own thinkability and getting you to think outside of the box. And if you have already read about the classic problems, then that becomes an hindrance. Are any advanced data structure required to reach expert, or just basic graph, DP, and ad hoc? To become an expert, I think basic graphs and DP are required, also segment trees, right? So in the batch that I have talked about, these are the kind of topics that you require to become an expert level coder, right? You require number theory, of course, that is required. You require DP. DP is required. DP is also required at really high levels. It is also required at really low levels. It is just what kind of DP level are you getting at, right? So the entry level DP is absolutely required to become an expert. Basic data structures, you should know that. Discrete mathematics. Then there is graphs, segment trees, advanced dynamic programming, computational geometry. I think if you read all of that, you can also reach candidate master as well, right? Just knowing everything in here with absolute certainty that you can solve problems based on this. That you have mastery. If you have mastery on these topics, then you can become a candidate master or master. Then let me talk about in contest strategy, right? CSS and final 450 questions. CSCS questions, those are the kind of the classical problems I was talking about. Again, those are good, but I think you should practice those just before an intern experience. If you're aiming to get your rating highs on Codeforces and Codechef, I think uh, you should focus on the contests themselves first, and the CSCS problem set. Maybe you should avoid that while giving contests. So, in contest, right? In contest, what you should be aiming at first is selecting the problems, right? So go for the easiest ones. That is kind of the one thing that everyone does, right? Here, it might happen that going for the harder problems is better for you, right? But most of the contest types that happen, the ICPC type and the IOI type, generally, what their formats make you to select the easier problems first, because they have a penalty according to the time. If you solve a problem later on, you will have a higher penalty, and if you solve a problem early on, you will have a lower penalty. So because of that penalty system and the scoring system, it is always preferable to go for the easiest ones, right? Sometimes it might happen you should go for the harder ones, but most of the time it's always preferable to do the ones that you can solve first, right? Sometimes in Codechef, it might happen that the problems are not given in any difficulty order, right? In Codechef or many other contests as well, like ICPC or the contests conducted by companies and stuff like that. In those kind of contests, the problems are not given in any difficulty order. So in there, you should spend some 5 minutes first searching for the easiest problem, right? You shouldn't just open up the first problem and start solving that immediately. You should see the first problem. Alright, this is a really long problem statement. Let's skip this for right now. Second problem, this is a small problem statement. Alright. Third problem, this is a long problem statement. Fourth problem, this is a small problem statement. Then compare the second and fourth problem. Read a little bit about second problem, read a little bit about fourth problem. Alright, fourth problem seems more familiar. So let's go on to the fourth problem right now. Start reading about that. And if it turns out that the problem was actually hard, then you can go to the next step, or if you solve the problem, then you can go to the next step. And the next step is, after you have searched for the easiest problems, regardless of whether you were able to solve that or not, afterwards go to the problems which have higher submissions. Alright, many people, if they have solved the A level problem, which is the easiest problem, they generally go to the B level problem, right, which is the next one, which is most of the time correct way to do it. But it might happen that the B problem was actually harder than the C problem, right? It might happen that just the writers or the contest organizers have messed up a little on their part and didn't put the problems to their true difficulty, right? They have not ordered it to their true difficulty. They kind of messed up and shuffled the problems around, right? So it is always beneficial to go for the problems of higher submissions. Let's say currently the B problem has like 50 submissions and the C problem has 100 submissions. Then you should see the C problem first. If you're not able to solve that, then go to the B problem. But you should see the C problem first, right? So this is another step that you should do. But again, this is the third step, and I think this is the hardest step for many people, including me. Sometimes even in my contest, it's just really hard to do this. That is to let go of problems. Let's say I have completed A, B, and C level problems. There are 6 problems: A, B, C, D, E, F, and I have completed A, B, C. I go to D. I start reading about that. I have spent 15-30 minutes trying to think of a solution, but I cannot think of that, right? And there are not many submissions forward as well. Let's say the A problem has like 10,000 submissions, the B problem has 5,000 submissions, the C problem has 3,000 submissions, the D problem has 1,000 submissions, the E problem has 100 submissions, the F problem is 50 submissions. Just give a thumbs up if you're comfortable in what I'm talking about, if you know what I'm talking about, if you have given this contest, right? If you do not know what the format of these contests is, I will spend like 2 or 3 minutes explaining what I'm talking about, what are the problem A, B, C, D, E, F, and what a general format of a contest is. Sorry, there are many thumbs up, so I think people know what I'm talking about. So I have completed A, I have completed B, I have completed C, right? I go to D, it has a higher number of submissions, I should go to D. I start reading D, I spent like half an hour or even 1 hour on it, I can't solve it, right? So I should learn to let go of this problem. I should just leave this problem and go to E, even if E has really less number of submissions. But I should at least look at that. I should at least have a look at E and try to see if I can solve it or not. Most probably I won't be able to solve that, but reading a problem doesn't require that much time. It just requires 5 minutes of time to read about a problem, right? This has two benefits, and these two benefits are really important, right? The first benefit is, like, you might have a advanced level knowledge that not many people have, right? Let's say for me personally, let's say I know about persistent data structures, right? Advanced topic, I know about that. Not many people are aware of persistent data structures. I'm just giving an example, but I go to but because I know persistent data structures, I can solve E, but I just don't know it because I haven't seen the question itself, right? If I see E, I know I will be able to solve it, and I will be able to, you know, uh, get higher ranking compared to the rest of the people. But if I had spent the rest of my time on D itself, I couldn't have solved it, right? So there is this benefit of trying to see the next problem, right? The second benefit that I'm going to be talking about is, if you're, let's say, not able to solve the E problem, and you have wasted 5 or 10 minutes in trying to read about the problem and realizing that this is too advanced for you and you cannot solve it, then you come back to D, right? You went from D to E and then you come back to D. Now your mind is reset in your logic part. Now if you see the D problem again, it might happen that new logics might come to your mind that weren't coming before. This is what I call a mind block, right? So you had a mind block on the D problem before, and you weren't able to solve it just because you were stuck on this one logic, and you weren't able to move on from that logic, and you weren't able to see the many excuse me, you weren't able to see the many observations that make this problem, right? So that mind block is reset by just reading about another problem, or you can even try to relax between a contest as well, right? One thing that I didn't talk about before, like in the short term preparation, just before like 15 minutes before a contest, I generally listen to music, the kind of music that hype me up, so that I can relax and focus on that music itself, right? So during sometimes in contests, what I do is just when I'm not able to do a problem and I have read the next problem as well and I know I cannot solve that, I just like take a break, spend 5 minutes to listen to a song that I like, and then come back, because that clears up the mind block I have, and just resets the logics in my mind, so that I can view the problem from a new direction now. Before I was just tunnel visioned on a single logic and I can't look at even other observations. But if you just spend some time doing some other thing, like maybe listening to music or going to the next problem, then when you come back to the problem, that mind block is reset and your tunnel vision is cleared and you can see new logics. This is a really important thing that I want to talk about, which is the mind block and how you can reset a mind block. So just give a thumbs up if you do understand what a mind block is and how you can clear this mind block, right? Because this is really important. In contest giving strategy, you should always have this in mind, that you might be tunnel visioned on a single logic. You are not able to see the other logics. You should have this in mind. So you should give a contest with having this in mind. You shouldn't just become depressed, like I'm not able to solve this problem even after I have given 2 hours on it, because you have given 2 hours continuously on it. That is why you're not able to solve that problem. If you had maybe like seen another problem for 5 minutes and come back to it, you might have cleared that logic that was in your mind before, which is the faulty logic, and you might have come onto a new logic. Then you might be able to solve that D problem, right? Also, like the fourth point, don't get worried in during a contest just because you're behind. Of course, the like clear way to do this, the most simple way to do this is just not to see at the standings during a contest. You can do that, just not look at the standings, just not see at the number of submissions the people have had, right? But that kind of puts you in a disadvantage, because if you do not see the number of submissions the problems has, you do not know which one is the easier problem, right? So you should see the number of submissions problems has. But let's say like 3000 problems have 3000 submissions have been made on C, and I'm still on the problem B, right? I'm really behind to what the top competitors are doing. So do not get worried because of that, because getting worried will just get you behind more, right? So you will just get further behind as if you're getting worried. You should just be focusing on the getting this problem done and getting to the next problem. I know it's hard, and I'm might sound cheesy saying this, but it really should be a little bit of effort on your part to change your personality so that you can get clear of the worriedness part or the pressure part that you have during a contest. You can try to relax in between a contest, that I have talked about. You can listen to music in between a contest if you are really just locked on a simple on a problem and you cannot clear it, right? So this is the selecting problems part, how you select some problems and how you go on about doing which problem first. And then there is a part of solving problems. When I am at D, what I should do to solve that problem, right? So this is the solving part, problems. So first, the most important point, which I feel most beginners mess up at, is the read the problems carefully. Let's ignore this part for now, right? So the read problems carefully and properly is the most important part in a problem. You should look at each line and try to understand what does each line mean, right? You should spend effort on that. It basically depends on your English knowledge and how well you are able to understand English, but you should be able to you should spend some time on trying to get these problems to trying to understand these problems. Let's take a break for 1 second. I think there was a doubt. Yeah, Nishant, what is the best problem for graphs? What is the best problem set for graphs? I'm not sure if there exists a single problem set for graphs. At least if there exists, I'm not aware of it myself. Pulkit Chabra arranged a curated problem set for his graph courses, so you can take a look at that if you're joining the subscription program. But apart from that, I think I'm not sure if there exists a curated problem set for graphs itself. And let me look at the YouTube chat one more time. Keep going. Any specific preparation to be done before to excel in Kickstart 2021 if one only knows the basic of DS Algo? Any specific preparation? No, I don't think so. Kickstart is basically just like how you give Codeforces contest or Codechef contest, right? It is basically like that. So Kickstart is as you prepare in Codeforces contest or Codechef contest. That's exactly how you prepare for Kickstart as well. Just keep learning, keep practicing, and you might be able to do problems in Kickstart if you're good enough. Gave a few contests on Codechef, got negative ratings in 4, all of them. Felt quite demotivated. So I'm going to be talking about this. I'm going to be talking about this in the what you should do after a contest, which is basically boiled down to do not get demotivated. That is the worst thing you can do, and I will logically explain why is that. But yeah, I will be also be talking about that why getting demotivated is the worst thing that you can do, right? It is hard to change your personality just because I'm saying so. That just don't get motivated, but you should spend an active effort in trying to change yourself so that you do not get motivated if you get a negative rating, right? I will be talking about that in the after contest strategy, but let us get back to the solving problems part. So you should read the problem first, that I've talked about. You should try to understand the problem completely with every little information contained in there. But sometimes the writer purposefully gives some information which is to deceive the contestants, right? Sometimes they might add that this number p that I have given, it is also a prime number, right? In the problem statement, it might be given that p is a prime number in the constraint parts or the problem statement part. Now it might happen that this information is useless because you were able to do the question if the p was not a prime number as well. Maybe the answer is just p plus 1, regardless of if p is prime number or p is non-prime number, right? So this is some information which is supposed to deceive the contestants, some extra information like p is a prime number, or the extra information might also be like in just written format, but which is like Rahul went to meet Sita during the day at 2 o'clock, and then he saw that the clock was actually at 3 o'clock. It might be something like that, but the final question is completely unrelated to whatever the story was telling about, right? So that might happen as well. That is easier to just ignore, right? Because there is generally a paragraph of story at the above part, and the actual problem statement is below. So you can just focus on the problem statement part. But this kind of extra information, like p is a prime number, which is supposed to deceive you and is in the problem statement itself, it is kind of harder to ignore. But you still have to take this in mind, because this might be a very useful and a very crucial piece of information that you might require to solve the problem. If you're not able to understand the statement directly, take the help of the examples given, right? Generally, there is the problem statement first, the statement. Then there is the constraints. Then in the input-output format. Then there comes the examples, right? The sample test cases or the examples. So this is the last part of the problem. That's why many people, if they are not able to understand the statement, they are kind of just get confused and spend most of the time on the statement itself. But if you're not able to understand the statement at any point, you should directly jump to the examples part and try to understand the statement line by line with the examples, right? The examples part are there just to help you understand the statement, right? So examples should be taken to understand the statement. Then once you have understood the problem correctly, go to the naive implementation. If there is a naive implementation, go to that first. Sometimes you might recognize the trick that is going to be used in this question immediately. That is where the experience part comes in. You are practicing 95% of the time because you get proper experience. So you can recognize the problem types. Maybe you see a problem and immediately understand, alright, this is a binary search the answer problem. You might understand, alright, this is a DP problem. And you directly go to that. But if you're not able to do that, if you're not able to directly jump to the problem type this problem might have, then you should go to the naive implementation first, and then try to look for observations that might be helpful in this problem, right? From this naive implementation, there might be, at some part, there might be overlapping subproblems. And if you see overlapping subproblems, then you might know, alright, this is a dynamic programming solution. There might be some update and query part, right? You have to update a thing and you have to query a thing. And you have to do this both at the same time. Then you might think, alright, then I might have to use a segment tree here, or there might be a mononotic function on which you have to search something. So you might think of, alright, then I can just apply binary search here, something like that. You can always look at observations on the naive implementation to try to get to the problem type that is required here to optimize your solution. Generally, why you have to, if you're new to competitive programming, you always most probably have to submit a optimized submission. The naive implementation mostly doesn't work, right? So you always have to try to improve your implementation in time complexity, so that you are able to solve that problem completely. And the next part is always analyze your algorithm completely before you code. You should look at each step your algorithm is doing on paper or in your mind, right? And understand the time complexity that code has, right? Get the total time complexity of your algorithm and the total memory complexity as well, right? Sometimes that is required as well. And see if the memory complexity and time complexity fits into the constraints, right? There is this constraints part given the question, and that is required to understand what the time complexity of your problem should be, and always to verify your algorithm before you code it, right? So always analyze your algorithm completely before you code. Do not go to code if you know that this problem is just going to get a TLE, right? If you know the problem, whatever you're coding is just going to get a TLE, you shouldn't code that. Sometimes you might not even know that. You might not know the time complexity of your code. You might be doubtful on that. So spend the majority of your time trying to understand what the time complexity is, and like if you're not able to understand the time complexity of code even after half an hour or 1 hour, then you might just code it and try to submit it. Most probably you will get a TLE, right? But on the off chance, like there is a 1% chance that you might get an AC. So you should code only when you know what the time complexity is, what the memory complexity is. You have analyzed your algorithm completely. Then only you should begin to code, right? Many people code first and then ask, all right, I'm getting a TLE. What should I do after this? I'm not able to understand why I'm getting a TLE, right? So that is not the correct way. You should know why. You shouldn't even code if you know you are going to get a TLE or a MLE, right? So that is the important part that many beginners fall to. They code first and then see, all right, I'm getting a TLE now. Now I have to improve. Do not focus on that, because you are getting a penalty of TLE, right? So you should know what your time complexity is even before coding. You shouldn't waste your time on coding. Good afternoon, Sunny Sarutana. After you have analyzed your algorithm completely and you know this algorithm is going to work, or at least you feel like this algorithm is going to work, right? Then you should start to code. And generally it is recommended to code fast, but I think it is more important to code correct. You should take your time coding, because it doesn't really require that much time coding compared to coming up with an algorithm. I think the ratio is like 3:1. 3 is the part you're trying to come up with an algorithm, and 1 is the part when you're actually coding, right? So maybe like if you took 30 minutes to solve a problem, then maybe 22 minutes you have taken up analyzing the algorithm, and only 8 minutes solving actually coding the problem. So it is not a majority part. You shouldn't focus on the fast part that much, but you should focus on the correctness part. Because if you get a WA, if you submit this code and you get a wrong answer, or a TLE or a MLE, something like that, then you have to look back at a code and understand where the bug is, right? And that is really time consuming. Trying to find bugs is more time consuming than taking the time to write correct code in the first place, right? So you should always take the time to write correct code in the first place, rather than just submitting a code that you feel like is correct and getting a WA, then getting to your code and trying to understand where the bug might be, right? But if you do get a wrong answer after submitting the code, you should try to find the bugs first. Then if you're not able to find any bugs in your code, then you should try to create tricky test cases, so that you can understand maybe what the algorithm that I came up with was originally wrong and I had to go to a new algorithm. Then you should try to create test cases so that you can prove your algorithm wrong, right? So any doubts after this? What kind of contest should an absolute beginner can appear in Codeforces and Codechef? You should appear for every contest. I was also going to be talking about this in a bit, but any contest that you can give, you should participate in it. Even a beginner is able to, solve div 2 problems, A or B problems. Long challenge which is going on right now in Codechef, the lunchtime which is going on, lunchtime not going on is going to come on Codechef. Also the cook-off. All of those contests you should participate in and it, regardless of if you're a beginner or an expert, right? You should get used to how you perform in a contest and how you solve problems in a contest. That is the more important part. Sir, do you have a personal blog or something? You can ask me questions on Codeforces itself. Codeforces or Codechef. You can message me directly there, right? You have the Codechef discuss page, or there is a messaging system on Codeforces. You can ask me problems there. Is it required to hold on to all the basic DS algo concepts and then move on to a peer contest to perform better without getting demotivated? I think it is much more efficient that you learn how to not get demotivated, right? You should learn how to not get demotivated and just appear for contests. That is much more efficient because you are getting practice for a contest rather than spending your time learning all of the DS Algo courses first and then getting onto the problems. That just means you're not getting any practice when you're studying DS Algo, right? So as you're learning DS Algo, the contest part is complementary. You should perform in contests, you should participate in contests as you're studying DS Algo, and that will help you to learn about this DS Algo part more. It might happen that you're not able to solve some problems because you do not know of some concepts, but that will just enable you to understand more that, alright, this concept I didn't know about, so I have to study about this concept, right? And also will get you more practice in like a contest type setting. So that is important. Please mention your Codeforces ID. So my Codeforces ID is Zeusors. Let me just go to the that page. This is my Codeforces ID, Zeusors, or my NM. I'm nm at codechef.com, right? Sometimes it is given that NNM are up to 5000 and the sum does not exceed 500 square. Yeah, that is because that also comes into your time complexity part. Whatever algorithm you're coming up with, right, that should uh, incorporate that part. That maybe the time complexity part is big of n plus m, right? That's why the sum part comes in, because you should focus on that n plus m is less than 500 square, something like that. Sir, any tips for beginners? Like, I just started coding and practicing only in long challenges for now. What should I do more? You should participate in more contests. As I think you should participate in as many contests as you can. On Codechef, on Codeforces, on AdCoder, on LeetCode, on HackerEarth. You should participate in contests because competitive programming in essence is participating in contests. That is the best practice you can get in competitive programming. So you should first participate in contests, and the rest of the time you can spend on learning and practicing on the topics that you're weak at and stuff like that. If class and contest are in the same time, then go for class, contest, or class. Uh, because there are so many contests going on, like right, I think you should go for a class first. If Because the class cannot be postponed. For a contest, you can give a contest later on as virtual as well, right? You can participate in this contest as a virtual contest, or you can just solve the problems that came in the contest in a contest type setting. Uh, and yeah, that would be enough. You shouldn't skip classes for contest, of course. uh, Now let me have some polls, right? This is some situational awareness problems which like test your knowledge about your in contest strategy. So you receive a wrong answer verdict for a very easy problem. What should you do? I've taken this problem from the exercise, I think 1.2.4 from Competitive Programming 3 from Srinath Alim. This exercise I found really nice, so I have taken some problems from there. So you receive a wrong answer verdict for a very easy problem. What should you do? Abandon this problem for another? That you're just skipping this problem for the next problem? Improve the performance of your solution? Create tricky test cases? Or in team contests, ask your teammate to redo the problem. So I'm going to be talking about each option, but let me have a poll first. And just answer what you feel like is the correct answer here. There is this options A, B, and C, and D on the bottom right part. You can answer what you feel like. On YouTube, you can just write A, B, C, or D on the YouTube chat, and I'll be able to see that. I'm seeing the YouTube chat as well. It's going fast right now, but let me take the Aditya Sharma question. Hi sir, I wanted to ask you that I started CP since June, but till now I'm not able to solve B problem on CEF, and also some time I took time 2030 on A problem. So that is most probably because you're not following the correct way to practice. That I'm going to be talking. What should your strategy be after a contest? After a contest is finished, how should you prepare to get better in the next contest that is going to come. So I'm going to be talking about that. Wait a second. B, C, or D. So here, many people have selected B, and many people have selected C. C is the correct one, the most correct one. Not the most correct one. I think the most correct one here is D, right? But if you have selected C or D, then that is correct. A is of course wrong because this was a very easy problem. Remember, you shouldn't skip a very easy problem, right? So improving the performance of your solution, that is also wrong. Many people have selected B, but here because it was a very easy problem, right? And you got a WA verdict. You didn't get a TLE, or you didn't get a MLE. So improving the performance of your solution isn't going to really matter here, right? And generally in very easy problems, the performance of your code doesn't matter as well. So B is wrong. Creating tricky cases, test cases is the most appropriate part. To see if there was a wrong answer, there must be some test cases on which it must be failing. And in team contests, what happens is that you might, again, that tunnel vision I was talking about, in this easy problem, you might have misunderstood the problem a little bit. That is why you're seeing it as a very easy problem, or that is might be like why like you're seeing as an easy problem, or that might be why you're getting a WA. So to avoid now you're going to get tunnel vision on that wrong observation you made, right? And whatever time you spend on it is going to be wasted because you have just misunderstood the problem. So asking your teammate to redo the problem without telling him anything about the problem. When you ask a teammate to redo the problem in team contest, just give him the problem. Give him some time to think about the problem himself. Do not try to put your own observations on him. That is the worst thing you can do in team contest. Let him think of the problem himself first, and he might come up with the correct solution immediately, right? So I think that is the best thing you can do in team contest. Ask your teammate to redo the problem. But if it is not a team contest, creating tricky test cases might be the most appropriate. TLE means that your answer is correct or anything else. If you do not know what TLE is, TLE means that your code is really inefficient, that it is taking too much time to run, right? Let's say n is given a less than 10 to the power 9, and you are running a loop for I from 0 to n, right? So you are taking 10 to the power 9 steps in your code, and 10 to the power 9 is really a really large number. So your code is inefficient, and that is why TLE comes, which means time limit exceeded. WA means your code is running in time but giving a wrong answer, and MLE means that your code is taking too much memory. That is also a cause of inefficiency. So TLE and MLE both are causes of inefficiency. One is exceeding in time, and one is exceeding in memory. If class and contest are in the same time, I have talked about that. So let me go on to the next problem. This is also a nice problem, right? So let me have a poller for this one as well. Let me talk about the problem a little bit. I'm going to be extending the class a little bit by 10 minutes, so please bear with me. So you receive a TLE verdict for your big O n cube solution, right? You have a big O of n cube solution. If you do not know about time complexity, basically you are running a nested loop 3 times, right? So you receive a TLE verdict, time limit exceed verdict, for your big O of n cube solution. However, the maximum n is just 100. What should you do? Again, the same options. I'm giving the poll once again. So this time what should be your approach? Abandoning this problem, improving the performance, creating tricky test cases, or asking your teammates to do the problem? Answer in this poll: A, B, or C, or D. For tier 1 colleges, what is the best practice for placements? Again, the best practice is of course getting yourself best in competitive programming in your college, and also I feel I am also in a tier 1 college, and I feel the practice is really similar to what happens in tier 2 or tier 3, just getting really good in competitive programming. It might happen that if you even get at an expert level, you still are in the really low in the ranking of your college, right? There are still 20 people above you, so you should just focus on clearing the interview coding test. You should be good enough that you can clear the coding test. You should be in the top 20 of your batch or something. If you are able to do that, you will be able to get through. So majority of the people on Unacademy selected B. The people on YouTube and some people on Unacademy selected C, which is the correct answer here. Right? Here, this is the correct answer. Creating tricky test cases. Many selected B to improve the performance, but I said the solution is big of n cube and the maximum n is just 100, right? So your big of n cube solution is doing 100 into 100 into 100 steps, right? N cube is 100 cube, which is 100 into 100 into 100. That is 10 to the power 6. And 10 to the power 6 is a really no number, right? It is not a high number. So this shouldn't TLE in the first place. You have created a correct algorithm, but it is just giving a TLE for some reason. So improving the performance of your solution is just a massive waste of time. You shouldn't be doing that. Many people selected B. That is absolutely wrong. You shouldn't be trying to improve your performance here. You should be trying to create a tricky test case, because it might be that your solution, even though it is big of n cube, you have implemented your code in a wrong way, and it is just getting into an infinite loop somewhere, or there might be some place where because the way you have implemented your code, the time complexity is greater than what you think big of n cube. So here, creating a tricky test cases is the best thing that you can do. Asking your teammate to redo the problem is wrong here as well, because your teammate is going because you have wasted your own time in this problem. So you should, and you have come up to an algorithm as well. So you should be the one focusing on the problem next. You shouldn't force your teammate to do this problem too, right? So creating the tricky test case is the best part. Just give a thumbs up if you do understand why creating the test cases is the best part here. Alright, let me have another poll, right? This is a similar poll. You have an n cube solution. The maximum n here is 1 lakh though, right? And you're still getting a TLE. The maximum n here is 10 lakh, 1 lakh, which is 10 to the power 5, right? This is the important part. So what you should do in this scenario, answer in this poll. How to get a chance for Google interview through off campus through CP. You should be really good in competitive programming if you are want to get a chance in Google interviews. I think at this time they have changed the method a little bit. Earlier they used to just shortlist CVs, but I think they are now taking a coding test. I'm not exactly sure, but in your CV, if you want to get into a Google interview just through your competitive programming, then you should be really good at competitive programming, and you should focus on getting your competitive programming to a level so that you can get shortlisted. So here majority of you people have selected the correct option, which is B, which is improving the performance of your solution. And you shouldn't create tricky test cases, because big of n cube is not going to work, right? You shouldn't have coded this problem in the first place, because you have a big of n cube solution and you have maximum n 10 to the power 5. So the number of steps your code is taking is 10 to the power 15, which is really large, right? So you shouldn't have coded the test coded the problem in the first place, but you have for some reason, and you're getting a TLE. Of course you should improve the performance of your solution. If you're not able to do the problem still, then you can abandon this problem as well, right? But you have spent some time on this problem, then you should try to focus on how to improve this problem and trying to get good observations out of this problem. But you can abandon this problem as well, right? And this problem, let's skip this point as well. Now this is the question that I wanted to talk about. You receive a TLE verdict for your big of n cube solution. The maximum n here is I have written 10,000 here, but the maximum n is sorry about that, it is just 1,000, right? The maximum n here is 1,000, not 10,000. The output only depends on the size of input n, which means maybe the problem can be something like this, that in the input it is just giving you a n, and for that you just have to give an answer, right? uh, let's say it is asking you to create a n size array, right? The problem is asking you to create a n size array with these conditions satisfied or something like that, right? It gives you a n and it asks you to create a1 a2 something an. So the output, whatever output you're generating, only depends on n, right? Only depends on the size of input n, which is n, and you still have 4 hours of computation time left. What should you do here? So this is the solution here is not in the 4 options before. The solution here, if anyone can answer, type it in the chat, or I will be telling the solution here in 30 seconds. But I want you to think about this problem for your own bit. This is also a problem, right? You have a problem and you're getting a TLE workday, you are having big of n cube solution, and you have 4 hours of computation time left. What should you do? So this is a problem, and I want you to think about this problem. And if you're able to get to the answer, just answer here. But let me look at the chart for a bit. Kill switch plays, but do you think having a better knowledge in software development, let's say AI ML, matters more than being better in CP for placements? That depends on how good you are at software development, but the general trend is that CP is much more important in getting you a good job. And also, even if you are really good in software development, there are coding tests for companies, and you should be at least good enough in CP such that you can clear those coding tests first. Then you can get to the interviews and share your knowledge for software development, but you should be good enough in CP such that you can clear your coding tests. Are lead code contest problems enough to clear the coding round of product-based companies? Matters which companies you're going to. Can you please tell that how do you manage academic projects in CP? That comes down to time management. You can ask me after the session. Right. So the solutions here, use Google for some hint. You can do that. I have sometimes done that, but you cannot do that in ICPC and IO type problems, right? You do not have an access to internet, and you shouldn't do that. Use fast input outputs. That is going to help. That isn't going to help because n cube here is 10 to the power 12. Sorry, 1000 cube, right? 10 3 to the power 3, not 10 to the power 12. It is 10 to the power 9, which is still a little large. You shouldn't do that. Use modulus percentage to avoid TLE. No. Optimize the solution. No. The solution here is really interesting. Just give me a second. My phone is ringing. So the solution here is to hard code your solution, right? Whatever answer you're going to have, right? Basically, let me make a new slide and talk about it here, right? Whatever answer you had on n equal to 1, you have that print that answer in a file, have that answer here, and just put that in your code, hard coded. Whatever answer you have for n equal to 2, put that in your code as well. N equal to 3, put that in your code as well. You can also get a script to transfer these solutions into your code, right? Basically, you're going to do this for n equal to 1000, right? So for each n, you're having a big of n cube. You're having a big of n cube solution to run it, right? So the total time complexity here is going to be how much? It is going to be big of n to the power 4, right? So big of n to the power 4, which is 1000 to the power 4, is 10 to the power 12. If I divide this by 10 to the power 8, which is 1 second in code time, right? You have 10 to the power 4. If I divide this by 3600, which is the number of seconds in 1 hour, it is around 3. So that was the critical information here, that you still have 4 hours of computation time left. So in 3 hours, you can get all of this solution on your personal computer, right? You can set up this code on your personal computer. You can have this code run in the background. You can get all of the solutions for n equal to 1, n equal to 2, n equal to 3, up until n equal to 1000. You get all of the solution, you hard code them into your code, and then just give the solution. Basically, if you have n equal to 3, you have the hard coded solution here. just give that answer to the tester, right? So this is the actual solution here, which is to hard code the solutions in your personal computer, run a code that such that you can get the solution for each n, and just put that in your code, so you are able to answer that in contest. Did you all understand this? Just give a thumbs up, because I found it really interesting, and I have used this one time in long challenge as well, right? Because it has 7 days of contest time. So this is some kind of tricks and tips that you can use in contest. This isn't used that much, but it was really interesting that I just had to share it, right? So I've also spent 10 more times. Let me talk about after contest strategy for 5 minutes, right? And then I will be ending the session with some doubts, right? So 5 minutes for this, and then 5 minutes for any doubts you might have. So after contest strategy, this is the majority of part that comes when you have completed a contest. Here only the half the job is done. After contest, you have to upsolve the problems that you couldn't do in contest. Upsolve is a term that is meant to just do the problems that you're going to do in contest. Let's say you were doing D when the contest finished. You still didn't able you weren't able to submit that problem in time, right? So you should solve D after the contest, and maybe try to do it yourself first. But if you aren't able to do it yourself, see the editorial and get that problem done, right? Whatever mistakes you did in this problem in contest time, you should remember these mistakes, right? Maybe it was a new concept that you didn't knew before, so you should try to remember that new concept. If maybe it was a new trick on a concept that you have already read, right? So you should remember that trick for the next contest. Maybe you knew the trick and you knew the concept for this problem, but it just didn't come to your mind during the contest time. So you should really try to remember this mistake going forward, that you're going to use in the next contest, right? So this is one part that many people miss, which is try to remember these mistakes, right? So you should try to remember these mistakes so that you can use them next. Discuss the problems. This is also a really majority of part in competitive programming. I personally discuss it with my on-campus friends, but many people do not have in real life IR friends into competitive programming. So you can have discussions on contests or problems online as well. There are many Discord servers. There are Discord servers for Unacademy. There was one for Indian Programming Camp. There is a dedicated Discord server for the people who subscribe to the Unacademy subscription program. There are Discord server for Codeforces and that as well. Many unofficial Discord servers as well. Also, you have the Codeforces blog system. You have the Codechef discuss system. So you can discuss the contests and problems there, and try to get involved in this discussions, because that is also help you in getting to know some new information that you didn't know before. Try to recognize your weaknesses. Try to recognize, like, I couldn't do a graph problem in this contest, so you should focus on graph next. You should try to focus on getting your graphs to a complete level, so that you can solve graph problems in the next contest that is going to come. So try to recognize your weaknesses, and the most important part, which I said for last, is don't sulk over your performance. Maybe you have performed bad, maybe you have got a lot of negative rating, so you shouldn't get demotivated by it. That is the worst thing you can get. You shouldn't get sad after performing bad in a contest. You should get angry after performing bad in a contest. There is a slight difference between here. Getting sad means abandoning competitive programming forever. Getting angry means you look forward the most to the next contest so that you can get your rating back, right? If you get sad, you are not going to attempt the next contest. If you are angry, you are looking forward to the next contest, right? There is a difference here. So you should be like, of course, this is a personality change, and it is not as easy as I'm telling you right now. Like, you cannot change your personality that easy, but you should try to put an effort such that you do not get demotivated. Because if you get demotivated, let's say if you're serious about competitive programming, really serious about your rating, you want to get your rating up, right? But you get your rating down, so you get demotivated. Now you are not going to get your rating up anyways. You have stopped caring about your rating at all, right? Now, if you do not care about your ratings anymore, you can give more contests, right? You shouldn't just leave competitive programming. If you do not care about your rating and just care about practice, you can perform in contests without caring about if your rating is going up or your rating is going down. Uh, so just don't get demotivated. That is the main thing. You should always, if you get a bad rating, if you get a negative delta, then you should try to prepare for the next contest and get your rating back up on the point in the next contest, right? So any doubts you guys might have, you can ask them in the Academy chat as well or on the YouTube chat as well. Let me look at the YouTube chat. Mm. How can I perform in contest if I'm really good at CP but my classmates are not, because I'm a tier 2, 3 college but I have friends from other colleges who are good. So in contests, try to get your friends into CP as well. I'm understanding you are talking about ICPC type of contest where you can only get uh, your teammates from your own college. But yeah, there you should focus on yourself more and try to get your classmates in a really like try to get your classmates in like practice sessions, right? If you're trying to improve on your own, you should have friends online as well so that you can discuss problems online. But if you're talking about ICPC, you should try to have a practice session with whatever teammates you have so that they can improve as well. At Coda beginning contest at 5:30 today. Yeah. What are the contests at which need to be given if the goal is only to crack the coding round of product-based companies? Still, you have to give all the contests, right? These contests are really helpful if you have the goal to crack the coding round of product-based companies. So you should be giving all the competitions: Codeforces, Codechef, Ad Coder, Lead Code, whatever you the sites may be. Thanks for the session. Thank you. What are the benefits of hackathon? As everyone say, just keeps focus on CP. Uh, Hackathons are combinations of CP, ML, development, many stuff like that. Hackathons are good as well, but yeah, first if you have to crack the coding round, you should focus on CP first. I'm stuck in DP segmentary. Please share some resources. DP and segmentaries. There have been courses on Unacademy for this. There have also been free live classes, so you can check them out. Sir, you are not audible. Am I not audible? Oh, sorry, I displaced my mic a little bit. Where can I buy CP3 book in India? You can get that through the Codechef uh, goodies page, and I think you can get that on Amazon as well, but I'm not sure. Alright, so again, we are starting a batch tomorrow, right? So this batch will be covering will be of 1 year and will be covering all of the topics starting you from the absolute beginning to the very end. So you can get a subscription on an academy to get availability to this batch, and it will be basically starting you from the absolute beginning and getting you to the end. And is there a batch for Java? Yes, there is a batch for Java. There is the C++ batch, there is the Java batch, and there is a Python batch. You can select whichever stream you like, and in all three of them you will be getting all of this, right? uh, I'm a FI BSc student. I'm excuse me, I'm not sure what that means. Is a batch for Java. Also, you can ask me questions later on at these handles. So I've already taken 18 minutes extra, so I'll be ending the class now. uh, I hope you enjoyed it. There will be a feedback session in the YouTube chat. There will be a feedback session in the description, and on an Academy. After the class is ended, you can fill the feedback form on the Academy platform itself. So do fill that feedback form, and yeah, I will be seeing you in the next class whenever it may be. So bye for now.